For the last intro today, it is someone who is part of the Sasso family. Let's give it up for Sello Mollo.
Good afternoon. You don't look excited to be here. Okay, I think as introduced, my name is Sello Mollo. As you may notice, my surname is Fire, and water and fire don't mix. And that's how I ended up being an electrical engineer. Okay, so just a few education places I've been to. I hold a Bachelor of Science in Electrical Engineering. So I'm a professionally registered engineer with EXA. I have got 2 master's degrees, one with University of Pretoria and Regent. I have got a government certificate of compliance with the Department of Labor, and I'm a member of the Institute of Electrical Engineers. I have worked with Eskom before. I'm not responsible for load shedding. And I've done some time at NATREF. I'm currently working with Sasso, and I've done some teaching at VUT before. Now, one would want to know, because I'm talking about an electrical engineer, what is an engineer? An engineer is a person who designs, they build things, they're responsible for maintaining some of the equipment that we've designed and some of the structures that we've done. And in particular, an electrical engineer only focuses on the design, development, and maintenance of electrical systems. Now, it looks obvious. I mean, everywhere we go, there is electricity, right? But there is somebody by the name of Edison that had to figure out how a bulb has to work. There is somebody that had to figure out why we have current, why we have what we have in the electrical space. Now, unfortunately, the field I work in, if you make mistakes, we don't talk to you, we talk about you. And that's why it's important that you don't kill yourself with electricity. You need to be an electrical engineer and understand the safety aspects. So on a day-to-day, what do I get up to? We do a lot of designs, and rightfully so, some of which you guys have seen, some might have not seen. This is the HVDC system, 765 kV. I think I worked on this while I was still at Eskom. At Sasso, we don't go up to these high voltages. But if you go to Eskom, they go up to 765 from Kahora Basa. We do some electronics. Obviously, what you guys are seeing here is not a township. It's not a town. But you can see some electronics that you are used to. So it's part of design. If you become an electrical engineer, the equipments that you saw here, this robotics, they work from the basis of some design that you need to do. And obviously, there is some programming that goes with this. I think critically, even if you are around this plant, you will see a lot of these plants. You'll see Sasso across the road. You'll see Eskom right across. But where an electrical engineer comes in handy, especially in the 4th Industrial Revolution, we need to be able to have somebody that can sit at home and know exactly what is happening in that piece of equipment. We need somebody that can be able to predict. You know, if you look at your car, for instance, right? So a tire pressure needs some electrical engineering to be able to know at what point is it going to go flat. An example is the tank level on a car. In the absence of an electrical engineer, if you look at the latest cars, they sort of can predict how many kilometers do you have to drive before you stop. In fact, in the next few years that we are in now, a car will be able to then, if you have 5 kilometers for some of our risk takers, because I know people that drive until the car says 0 kilometers. We are seeing in the near future that the car will then manually force yourself and drive itself to the next filling station. But this is what electrical engineering, so if you are in this field, this is what will be expected for you. So in a plant like that, you must be able to assist your chemical engineers, your mechanical engineers, to be able to monitor and predict what is going to happen. So with artificial intelligence, some of these things we are able to predict the life expectancy of some of these things. So if you think future, you have to think electrical engineering. You've seen some of these things, and we are operating plants that are completely dangerous. Some of the plants around this area, if they can go wrong, they can wipe out the whole of the valve. So it is important that as an electrical engineer, you have the right instruments to be able to monitor what is happening. And I think in the maintenance space, you must be able to say, in so many kilometers of running a vehicle, you need to take maintenance. I mean, the guys that I know BMW, one thing nice about BMW is that you don't service your car every 15,000 Ks. It's called artificial intelligence to be able to predict at what point, given the way you drive, some people take it up to 30,000 Ks, some 20,000 Ks. It depends on how you drive. So as my duty as a maintenance guy, I need to be able to monitor these things and predict the life expectation. So in the years that we are in now, there's a lot of artificial intelligence that is being introduced and we are using to predict some of the failures and to be able to see things before they go wrong. Unfortunately, in the space that we are operating in, you need to be governed by certain rules. And I think my role in this space, you cannot just have electricity that is not governed because it becomes a problem. That's why if you go to spaces where you've got wires that are not correctly designed, is nyoga, right? You see a lot of people being injured because of failure to meet the requirements, failure to operate and design to the right regulations, failure to operate and design to the right policy. And my duty as an electrical engineer is to make sure that at Sasol, all of these things are complied with. Now, if I were to write this in a nutshell, if I'm an electrical engineer, my duty is not just to connect the two wires. So if you do consider this field of study, you've seen the robotics that we're here. So when we speak electrical engineering, we are talking anything from 0 volts right up to 765 in this country. So if you talk 400 kilovolts, if you are talking 500 volts or 380 or 220 as you use in your house, in the space that we are in, we work around 88 kV, which is 88,000 volts. So you can take the 220 that you use at home and you convert that to 88 kV. So in a nutshell, my duty is to design, develop on daily basis. I have to supervise the machinery and make sure that we are operating those equipment to the right specification. I have to evaluate and see all the electronic compliance and the components that we have. And lastly, I have to assist with process troubleshooting. I think in a nutshell, it gives a background of what an electrical engineer does.
Mr. Mollo just had an amazing talk, and I think if you guys were paying attention, you got to learn about what his day in his profession looks like. Now, if anybody here aspires to get into the same industry as him, work in a place like Sasol, I think it's best that you take this opportunity right now to ask him any questions. So we're going to have mics that are going around. If you have questions, please do ask. We don't know when you're ever going to get a chance like this again, okay? Do we have any questions? And while we wait for that, I think I had a question for you as well. I mean, you spoke about at the beginning, you said that you don't want to get electrocuted in a situation like this. What are the safety precautions that you specifically have to take account of when you're working?
Can I just answer the question differently? Maybe the first things first. Please stop putting your chargers underneath your pillows. Your phone underneath the pillows. So that's one, it's a no-go, right? So secondly, obviously your electrical cables must not be exposed.
Okay.
So one of the things that I'm interested in is to make sure that the insulation is always intact so that no one can be able to accidentally touch it. Mm-hmm. And should you then touch it, there must be protection devices that will then protect you. So I do those designs to make sure that you'll see it in your house. If you touch anything, a breaker trips in your DB. That's part of what I do to protect the equipment, protect the people that are working around.
Can I ask you to explain something to me? This is a bit of a dummy question, but we're waiting for questions to come up. So at home, we have an air conditioner. And
Yes.
every time I put it on, especially on the heater, because it's winter now, the earth leakage trips.
Yeah.
What does that mean?
So your equipment is designed for the power protection that you have. So it means you are overloading your supply. That's all it means. Because depending on whether you are on cooling or you are on heating, the air condition operates differently. So if you put it on heat, you are overloading your supply, and that's why it trips.
And lastly, do you have any advice to the kids who I think are a bit nervous to ask a question? Any advice to them that if they want to get into this field?
My advice is that the future of the organization, I mean, we talk electricity, we talk ESCOM.
Yes.
When we talk electrical engineering, everyone is thinking load shedding, but it's bigger than that. That's why I use the example of the robotics, because robotics is a portion of electrical engineering. And in the era of the fourth industrial revolution, where we are talking artificial intelligence, robotics is there. We need young people that can design systems that are smart enough to be able to predict the future. And it sits in the electrical engineering space.
So basically, everybody in this room, every young person in this room has the responsibility to come and solve all of those problems.
Yes.
Are you guys ready to take that challenge? Are you guys ready to take on that responsibility? Well, thank you so much for that wonderful talk.